Let me first introduce you to the source of our input dataset, that is Comet's LIXAR system for generating open interferograms from Sentinel-1 data. For more information, please see e-poster of ID 404. In this study, we investigated basic LIXAR frame units that cover area of around 260 times 260 kilometers and consists of 39 bursts in total. The network of generated frame interferograms can be used for a time series analysis, for example by our open source tool TixPass. Here we investigate the use of spectral diversity values that basically represent a subpixel azimuth shift of a scene with regards to primary scene. We convert spectral diversity values to metric units and use Huber loss regression to filter outliers and estimate the rate of motion in the azimuth direction of the satellite orbit. For this particular frame, we have estimated a mean average deformation rate of around 10 mm per year in the direction towards approximately south. The expected value from ITRF 2014 blade motion model is 1 mm per year higher in the same direction. Solid earth tides contribute to the azimuth shift. We can see its effects also in the frame interferograms. Here we have used a solid model implemented in GMT earth tides module. The effect of solid earth tides correction is relatively small. The velocity estimate changed by 1 mm here and is now closer to the ITRF 2014 value. The ionosphere contributes more significantly. We have used the International Reference Ionosphere 2016 model to retrieve total electron content in between ground and the satellite at its position during observing burst edges. From the TEC values, we have calculated the azimuth shift. We have implemented two solutions to estimate ionospheric effects. The second solution is considering projection of the scene to the top side of ionospheric layer. The use of F2 layer heights from the model decreased the correction amount. In following slides, we have used the former solution. As you can see, the ionospheric correction flattens the time series within the frame. However, the final estimate deviates significantly from the ITRF value. Let's compare the results with an overlapping Descending frame. In both cases, the estimated velocities are similar, 12 or 13 mm year towards south. The ionospheric correction flattened both time series. However, their estimated velocities now differ. As conclusions, we can monitor large-scale displacements in azimuth direction using spectral diversity values. The effect of solid earth tides should be taken into account. It's necessary to investigate further a better modeling and correction of ionospheric effects and study the tropospheric effects, which can be significant in the case of large seasonal bodies, as for example monsoons. As a final note, we have observed offsets in spectral diversity values in a number of frames after the change in precise orbit definitions in the mid-2020. The POD difference is also observed in the line-of-sight interferograms. Thank you for attention.